Hello class, in this lesson we're going to learn how to complete proofs that involve isosceles triangles. Remember, an isosceles triangle is a triangle that has at least two congruent sides. So here's a refresher on the 5 congruence criteria. These are going to be useful throughout our unit. Now in a previous lesson we learned about this theorem and its converse. We know that if we have two sides of a triangle congruent, that the angles across from them, or the base angles, are congruent. And the converse of that is also true if we flip that around. If we know that the angles, we have two congruent angles, that those opposite sides, or the legs, are congruent. Now, why is the base angles theorem true? We're going to prove that using side angle side. So here they give us an isosceles triangle, and they tell us that AB equals AC. So our first given is going to be that statement. You can write isosceles triangle ABC if you want as part of your given. You don't have to. What's important is that you know which ones are the legs. And we know that we want to show that angle B and angle C are congruent. So any thoughts on how we can get there? Now we want to do a side angle side proof, it says up here, but we only have one triangle. So think of what you could draw in the diagram that would help us get to this conclusion with two triangles. What could we draw that would be helpful? Well, you want two triangles, so we should draw a segment that goes from one of the vertices to the opposite side. And what's going to be useful here is the angle bisector of angle A. That's going to help us get to our conclusion. So here's the angle bisector, and we call this point down here D, where it meets the opposite side. So in order to get to the last statement, angle B is congruent to angle C, let's say that these triangles are congruent first. So what are the two triangles that we have? Triangle ABD and triangle ACD. And they already told us that we want to use side angle side. That's going to be our reasoning for our triangles being congruent. And once we know that the triangles are congruent, then we know that all of their corresponding parts are also congruent. All right, you can use the term triangles here, but you could also say figures. That's more general. Okay, so what are we missing here? Well, that's given to us. So we have a side. We have AB. We have pair of sides. We have AC and AB. We need another side, another pair of sides. So what can we say is congruent in both triangles? Well, the reflexive property here, right? We have AD is congruent to itself, and that's in both triangles. Now we just need the included angles to be congruent. We know that that's true because we have an angle bisector. And there's our proof. So now we know that the base angles are congruent. So here's some more properties to think of. What types of angles do you get down here where the angle bisector touches segment BC? What types of angles do we get here? Well, you know that these are congruent and they're also supplementary. So they both have to measure 90 degrees. So they are right angles. The only way that you have congruent supplements is when they're both 90, because 90 plus 90 is 180. There's no other measures that are going to get that done for you. And what does that mean about the angle bisector? Well, we know that the BD is equal to CD, because those are corresponding parts. So that is also a perpendicular bisector of the base. It's an important property. Let's look at a few more proofs involving isosceles triangles. So I filled in the givens already for us, and our final statement that we want to prove, our conclusion. So how can we get to the conclusion? Let's see, we have JKL is isosceles, and the legs are JK and JL. They give us that. They tell us that KX right here is congruent to LY. And we want to prove that this inside triangle, JXY, is isosceles. So what do we need to show in order to prove that it's isosceles? It has to have what? It has to have at least two congruent sides. And those two sides, based on the diagram, look like they're going to be jx and jy. So it should be our second to last statement. And then once we know that that's true, then we can say that we have an isosceles triangle, because that's the definition of isosceles triangle. Now we just got to fill in the middle part. So how do we get to showing that jx is congruent to jy? Well, it's looking like these triangles kind of on the edges here are congruent. And how can we show that? Well, they gave us the legs, so we can say the legs are congruent. And this just comes from the definition of an isosceles triangle. And so that's what we marked in green already. And it's looking like we should say something about the base angles here. You know, the base angles are going to be congruent. So we have angle K is congruent to angle L by the base angles theorem. And now, are these two triangles congruent? Yes, they are, because of side angle side. We have triangle JKX congruent to triangle JLY. And so why are segment JX and segment JY congruent? Because they're corresponding parts of congruent figures. Here's another proof of isosceles triangles. It's going to take a little bit more work to get to our conclusion. So we want to show that triangle JKL, the larger one, this time is isosceles. That's going to be our conclusion at the end. And all they give us to start with is that JX equals JY and KX equals LY. So now we're working from this inside triangle to the outside. So we have an isosceles triangle. So what can we say about the base angles? We know that they are congruent. So they have the same measure. Now notice in this problem, we're just talking about the measurements here. So Jx is just a number. So that's why we're not using the congruent symbol or the segment on top. And what can we say about angles 1 and 3? What's special about them? You know, they're supplementary. They're a linear pair. So they add up to 180 degrees. And we can say the same thing for angles 2 and 4. Okay, so how does this help us out? We want to show that larger triangle is isosceles. And it's looking like we have pairs of sides congruent here. So these two legs and these two on the bottom. So we want to get those included angles congruent so we can prove this using side angle side. So how can we show that angle 3 is congruent to angle 4? So this looks like we might want to do some substitution so we can get 3 and 4 in the same equation. So let's take this one right here, the one that involves angles 1 and 3. Let's solve that for the measure of angle 3. So if we apply subtraction, we know that the measure of angle 3 is 180 degrees minus the measure of angle 1. And we get something very similar for angle 4. So these two expressions look very, very similar. There's one thing different in them. One of them says angle 1 and one of them says angle 2. But what do we know about angles 1 and 2? We know that they're congruent from up here. So if we use substitution a few times, all we do is replace the, say we could replace this measure of angle 1, measure of angle 2, and replace this measure of angle 2 down there with measure of angle 1. And so, measures of angles 3 and 4 are equal. That's just by doing substitution a couple times. And so now we have congruent triangles. And when we name them, we can say triangle JKX is congruent to triangle JLY. So these two on the these tinier ones on the outside. And we want to say that we have an isosceles triangle So it looks like the two legs we want are JK and JL. Those are corresponding segments. And so now we have two congruent sides, so it's an isosceles triangle by definition. So there's the entire proof. Finally, here's one that has the Triforce from Zelda in it. And this is a nice shape for geometry, has a lot of nice properties. And we can use it to solve this proof. So they tell us that side AC, the measure of side AC is the same as the measure of side AE, and that BF and CE are parallel. So we should be thinking about our parallel theorems that we know. Alternate interior angles are going to be congruent, corresponding angles will be congruent, etc. So we have those. These are parallel. Let's put little hash marks on our large sides. So AB is congruent to AE. And it's given to us. So we want to show that AB equals AF. How can we get there? Well, it looks like this triangle up here, triangle ABF, is isosceles. You have to prove that. But if we know it's isosceles, then we know that those legs are going to be congruent. So let's try to show that it's isosceles. So to start off, we have our first given here. Remember, you don't have to list all your givens at once. Just put them in the order that you need them. So this is sometimes more useful or easier to follow. So AC is equal to AE. And what should we be thinking about now that we know those sides are the same? We know we have what type of triangle? The triangle is ACE. It's an isosceles triangle. And that's by definition. Okay, the next logical step is that since we know it's isosceles, what do we know about the base angles? You know that they are congruent. And it's a base angles theorem. So how's that going to help us get to our goal? We want to show AB equals to AF. So we want to make this isosceles. So we want to try to talk about angles B and F, because those are the base angles. So think about what types of angle pairs we have. So we know that segment BF is parallel to segment CE. And now what can we say about angles ABF and ACE? We know that these are congruent because they're corresponding angles. So since the lines are parallel, the corresponding angles are congruent or equal in measure. And we can make the same argument over here with angle AFB. So all those angles marked in red are congruent. So how can we write that formally? So we want to show that angle ABF is congruent to angle AFB. So let's see, where's that? We have ABF, AFB. I want to show those are congruent, but they're both equal to these angles, which are congruent from up here. Those measures are equal. So this is just another form of substitution. So now that we have that, what can we say about the triangle? Well, the base angles are congruent, so we know that those legs are congruent, so we must have an isosceles triangle. So your triangle is isosceles now. And since it's isosceles, you know that those legs are congruent by the definition. So that's what we wanted to prove. In this video, we learned how to do proofs using properties of isosceles triangles. Thanks for watching this video.